Alright guys, we have another exciting problem here again, and this is a circle of course, and we want to find the area of the shaded part. Just like you can see, this is the shaded part here. Now before we find the area of the shaded part, let us discuss very quickly about this region of the circle. This region is called a sector. The whole shape you see right here is called a sector. The big guy is a sector, right? So don't mind my diagram. So that means, and within that sector, we also have a triangle. And fortunately for us, the triangle is a right angle triangle because it has one of its angle to be 90 degrees. So it's a right angle triangle. So what it means is that if I can get the area of the big guy, which is the sector, if I can get the area of that big guy, which is what? The sector, right? Then I remove the area of the triangle, which is this guy here, from the area of the sector. What will be left is the area of the shaded part, which is this segment. Of course, you know this is a segment, right? So if I can successfully get the area of the whole sector, number one, then secondly, I get the area of the triangle. So when I remove the area of the triangle from the area of the sector, then I will be left with the area of the shaded part. I hope that point is clear. So now, with that illustration, let us go right into solving this problem. Now, what is the area of a sector? First of all, let's say to get the area of the shaded part, the area of the shaded part, it will be equal to the area of the sector minus the area of the triangle. I hope you get this point, right? So once we can successfully do this stuff, we'll be left with the area of the shaded part. So let's get the area of the sector. It's just simply theta over 360 times pi r squared minus the area of the triangle is just half times base times height, right? All right, so now let's move forward. Before we slide up to the next side, let's observe some things here about the triangle. Remember, this triangle has a radius 8 and the sector has an angle 90 degrees. So for this case, my theta is 90 degrees because the sector has a 90 degrees angle. So here become 90 degrees upon 360 times pi r squared. You know, the radius is r, which is 8. So that is 8 squared is 64. That would be like 64 pi, right? Then minus half times the base of the triangle is either 8 or this one. This could be the base, it could be the base, this could be the height, this could be the height. It depends on how the triangle is sitting. So for this case now, we can see that the base here is 8 and the height is 8. So any of them could be the base or the height. It doesn't matter. The hypotenuse can never be your base nor your height. You can either get the base or the height from the legs of the triangle. So that means I have 8 times 8 here, which is now 64, right? So finally, moving forward, if I simplify these guys, this is 1 and here is 4, and we have 1 over 4 times 64 pi minus this one will give me 2 into 6 is 3 and 2 into 4 is 2. That's 32, right? And of course, you know 4 can actually divide this guy. 4 here is 1, 4 in 6 is 1 remainder 2, and 4 into 4 is 16. So that would be like 16 pi minus 32. That is the area of the shaded part. So I think that's the final answer. Thank you very much for watching and see you in the next class. Bye bye.